Alright, in this lesson we're going to be looking at solving multi-step linear equations. So in the following examples, you're going to solve for the unknown variable. Solve 4x minus 3 equals 8. So again, as we talked about in class, we have to move everything over on the left side, with the variable in this case on the left side. So we have to move everything over that's not an x to the other side. So how do we move then? I use that term move very loosely, right? So we ask ourselves, how are this 4 and the 3 connected to the x? Well, the 3 being subtracted and the 4 is being multiplied. So we have to move both of those. So I have two options. Let me show you both options, and one of them is definitely easier than the other. So let's go with the first option here. Let me go ahead and add 3 to both sides. Okay, so that's going to cancel on the left, so I'm left with 4x equals 8 plus 3 is 11. And finally, let's divide by 4. Except 4 is being connected through multiplication. I'll rewrite that as x equals 11 fourths. Now let's look at this another way. Just to show you, it doesn't matter which one you do first. So if you're struggling, if you spend several minutes trying to figure out which one to do first, don't worry about it. One of them is usually easier than the other, but algebraically they will all work out the same. So if I want to take care of multiplication first, so let's get rid of this 4. I have to divide through by 4. These 4's cancel here. So I have x minus 3 fourths equals 8 fourths. Now this is not looking as pretty as the other one, right? Because I introduced fractions really early. And now I'm going to have to add 3 fourths to both sides. Let's cancel. X equals 8 fourths plus 3 fourths is 11 fourths. So exactly the same answer, just two different ways to do it. When I'm working these next few examples, I'm going to always try to pick the easiest way to do it, just so you can see that being modeled. 4 minus 2y equals 11. Again, I've got the y, I've got to isolate. How's that 4 connected? It's understood to be addition, right? So I'm going to subtract 4 from both sides. What you don't want to do, and a common error, is to use the side to the right of the number. Don't do that. That minus sign is applying to the 2, to 2y actually. So let's cancel out the 4's. I'll have a negative 2y equals 11 minus 4 is 7. Down to my last step, I have to remove that negative 2. It's connected through multiplication. I undo multiplication with division. So I'm going to get y equals, and again I usually bring that negative up, negative 7 halves. Wouldn't be wrong if you left it down. Just looks a little better in the numerator or directly out to the side. Example 3. 1/3 x plus 3 fourths equals 5. A couple options here. We could go and begin subtracting 3 fourths, multiply through by 3, but I'm going to recommend that we clear fractions first. Okay, so I need to multiply by the LCD. What is the LCD in this case? We'll look at each denominator, the 3, the 4, and this is over and understood 1, right? So what number will both 3, 4, and 1 go into? 12. Good. So I'm going to multiply each term here by 12. So the 3 goes into 12 4 times, and the 4 goes into 12 3 times. And then do the arithmetic. 4 times 1x is just 4x. Then 3 times 3 is 9. And then 12 times 5 is 60. So some of the common errors that are made here are if you multiply the left side by the 12, you have to multiply the right side. Even if there's not a fraction over there, we still multiply. Whatever we do to one side, we do to the other side. Now that we have it like this, 4x plus 9 equals 60, it's pretty much like the problems we've been working all along, right? So I'm going to subtract 9 from both sides. 4x equals 51, and then divide by 4. So I'll get x equals 51/4, and I cannot reduce that any further. Now, if we didn't have a calculator, this is one, if I were taking this on a test, I probably would not check. Why? Well, because the checking of the problem may be more challenging than the actual solving of the problem. When that happens, I usually don't check it as much. Or if I have time, I go back and check it and really make sure that I didn't mess up in my checking. So I leave that checking up to you on all of these, in fact. Okay, solve 3w plus 4 equals 5w minus 6. So now I've got a variable on both sides of the equation. It doesn't matter which one we take care of first. I generally will get the variable to the left-hand side. So, with that said, let me subtract 5w from both sides, because it's understood plus here, right? Now we could subtract 4 in the same step, but I'm going to wait and do that in the next step. But you're certainly welcome to do that. So 3w minus 5w, negative 2w, plus, then bring down your 4, equals a minus 6. So what we see here is that this is really similar to what we've been getting all along. Once you get it in this form, sort of like the ax plus b equals c form, we ought to be able to do it pretty quickly. Now in the beginning you won't be able to, but once we work through a few of these, it ought to start clicking for you. So I'm going to subtract 4 from both sides. I have negative 2w equals negative 10. And one more step. Good. Divide by negative 2. So I end up with w equals 5. Ooh, another one with fractions in it. This one has several more. But we don't change what we do with these, right? We look at each denominator, and it's probably easiest if we multiply by the LCD. And what is the LCD in this case? The lowest or least common denominator. What number will all 4 of these go into evenly? 12. Good. So I'm going to multiply each term by 12. Okay, so 2 goes into 12 6 times. 3 goes into 12 4 times. 4 goes into 12 3 times. And 6 goes into 12 2 times. And then 6 times 1 gives me the 6x. 4 times 2 gives me the 8. So minus 8 equals. And 3 times 3 is 9. And then 2 times 1 is 2. Oh, sorry, 9x. Don't leave out the x. Plus 2. I know it looks a little sloppy up here. So you may need to rewrite that step sort of to make your notes look neat. Okay, now it's pretty much like the last problem we did, right? So I can subtract 9 from both sides. Sorry, 9x. Now watch this. I'll go ahead and do it in this one. Let me go ahead and add 8 to both sides, because I'm going to have to move that 8 over. It does save us a step. 6x minus 9x is a minus 3x. Bring down your equals. 2 plus 8 is 10. One step away. Divide by 3. So I get x equals, let's bring that negative up, negative 10/3. Okay, solve 2 times the quantity a minus 3 equals negative 5 times the quantity 2a plus 1. So our first step here is to clear parentheses. Clear parens is my shorthand way of saying that. So I'm going to multiply the 2 to the a and the minus 3. And we had a whole lesson on doing this. So let me get this. So 2a minus 6 equals, and the same thing with the negative 5. Multiply it to everything in parentheses. So negative 10a minus 5. Again, I get the a's to the left, so I'm going to add 10a to both sides. And I'm going to have to move that minus 6 over, or I can do it in the same step. So 2a plus 10a is 12a equals 6 minus 5 is 1. All right, one more step. And divide both sides by 12. And I get a equals 1/12. Example 7. Again, we kind of have a sneaky one here, right? We have an understood -1. 3 minus the quantity x plus 2 equals 4x minus 1. Do not try to do this without writing it down. Let's go ahead and clear parens. So 3 minus x minus 2 equals 4x minus 1. We have a couple options here. I generally recommend that you try to clean up what's on the individual sides before moving left and right. You don't have to. It just seems to cut down on some errors. So I can combine this 3 and the minus 2 to get 1. So I'm going to have negative x plus 1 equals 4x minus 1. Okay, so I'm going to subtract 5x from both sides. Subtract 1 from both sides. Sorry, 4x. Not sure where I got that 5 from. Okay, let me start over here. Subtract 4x from both sides. Those cancel, and subtract 1 from both sides. Those cancel. So I'm going to be left with negative 5x, that's negative 1x minus 4x, equals a negative 2. Last step, divide by negative 5. And I'm going to get x equals, we have two negatives, so we can just cancel those out and make them positives. So two negatives make a positive. Okay, if you're pretty comfortable solving equations, you don't need to go on. These are further examples. I'm going to recommend that as soon as you see the examples, pause it, see if you can work those, and then watch me do the solution to check your answer. Solve 5x plus 2 equals negative 8. So, I know you're going to pause this, you're going to work all these ahead of me, and then come back and see how we did. I'm going to subtract 2 from both sides. So I'm going to work these fairly quickly. Equals negative 10, then divide through by 5. I'm going to get x equals to negative 2. You should check all these. I'm not doing that, but you should. 5 times negative 2 is negative 10, plus 2 is negative 8. At the very least, mentally go through these that aren't fractional. Negative 3x minus 7 equals 16. So I'm going to add 7 to both sides. I'll have negative 3x equals 23, and divide by negative 3. So x equals negative 23 thirds. Solve 3x minus 2 equals negative 5x plus 3. Getting the x on the left, I'm going to add 5x to both sides. And at the same step, I'll go ahead and add 2. 5x's cancels, 2's cancels, 3x plus 5x is 8x equals 3 plus 2 is 5. Last step, divide by 8. So x equals 5/8. This one a little harder to check mentally. If you've got a calculator, you can plug it in and check it that way. Okay, 3x minus 2 minus 4x equals 2 plus 6x minus 1. We got a lot going on here. As I mentioned earlier, probably best if you will combine your like terms on each individual side before moving left and right. You don't have to. If you're very careful, you can still do it that way, but I like doing it this way. So I'm going to have 3x minus 4x is a negative x minus 2 equals, let's go ahead and combine the 2 and the minus 1 to get a 1. So we have 1 plus 6x. Okay, so I'm going to subtract 6x from both sides. Those cancel, and at the same time I can add 2. So negative x minus 6x is a negative 7x equals 3. Divide by negative 7. Those are going to cancel, and I'll get x equals a negative 3/7. Example 11, solve 1/3 x minus 1/2 equals 3/4. Again, another one where you have to find the LCD and clear fractions. You don't have to. You can multiply. You could add 1/2, multiply by 3, and get it. Not that big a deal. But when these equations get a little bit longer with more fractional terms, it's easier to find the LCD. So the LCD here is going to be 12. Now, technically, we don't have to get the L. We don't have to get the least common denominator. We can you can get the largest one if you wanted to. It'll all even out in the end. You could have picked 24 if you wanted to, or 36. Those fractions end up dividing out by the end. So long as we do what we do to one side, we do to the other, we'll be okay. So multiply through by 12. So 3 goes into 12 4 times, and this is normally what I do. 4 times 1x is 4x. Minus 2 goes into 12. 6 times 1 is 6. Equals 4 goes into 12. 3 times, and 3 times 3 is 9. Now, we're going to add 6 to both sides. And by this point, we should be getting pretty good at doing these. So 9 plus 6 is 15. And the last step is divide by 4. Again, I'm not explaining these steps like I was earlier. This is just further examples. X equals 15/4. Okay, I believe this is the last example. Negative 3 times the quantity x minus 2 equals 4 times the quantity 2x plus 3. We're going to clear parens. Clear parentheses here. So the negative 3 onto both of these guys, and the 4 onto both of the terms in the parentheses. So negative 3 times x is negative 3x plus 6 equals 8x plus 12. I'm going to subtract 8x from both sides. At the same time, I'll subtract 6. 6 is canceled. So 3x minus 8, negative 3x minus 8x is a negative 11x equals 12 minus 6 is 6. Last step, we'll divide by negative 11. I know I'm going a little fast, but I was assuming that, hopefully correctly, that you would have paused and tried and done this on your own. So negative 6/11. And that's it. So solving equations, very important. We'll use it pretty much in every chapter that remains in the class.